Sum of interior angles in polygons. In earlier units, we spent a lot of time studying one specific polygon, the triangle. We don't have to spend that same amount of time on each new polygon we study. Instead, we will be able to use what we learned about triangles to save a lot of time and effort. Here is a review of the triangle sum theorem. The sum of the measures of the angles of a triangle is exactly 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. A diagonal of a convex polygon is any segment that joins two non-adjacent vertices. So here we have the diagonal from A to C, the diagonal from B to D, the diagonal from C to A, and the diagonal from D to B. Counting diagonals by the number leaving each vertex results in each diagonal being counted twice. A convex quadrilateral has two diagonals, not four. So we have this diagonal and this diagonal. Here we have a pentagon. Counting diagonals by the number leaving each vertex results in each diagonal being counted twice. A convex pentagon, 5 sides, has two diagonals drawn from each vertex, so here and here, there and there, and so on. So there's 10 when you count them this way from each vertex. Therefore, a pentagon has 5 distinct diagonals, because if you count from the number leaving, you get twice as many as there actually are. So here we have 1 diagonal, 2 diagonals, 3, 4, and 5. So a pentagon has 5 diagonals. Fill in the cells of this table, including an expression for the number of diagonals of a convex polygon based on the number of its sides. Alright, so for a polygon with 3 sides, a triangle, there's 0 diagonals, since all of these vertices are adjacent to one another. If there's 4 sides, a quadrilateral, we have 2 diagonals. If there are 5 sides, we have 5 diagonals, which is what we did on the previous slide. It looks just like that. 5 diagonals. For 6 sides, we have 1, 2, 3 diagonals coming out of one vertex. So how many vertexes are there? 6. How many come out of each one? 3. So that's 18. Then we divide by 2 and we get 9. There's 9 diagonals here. Alright, here we have 7 sides, so there are 1, 2, 3, 4 diagonals coming out of one vertex. So if there are 7 vertices times 4 diagonals, that gives us 28. Divide that by 2 and we get 14. So what is our rule for determining the number of diagonals? It is right here. For n amount of sides, we have n times n minus 3 divided by 2, and that gives us the number of diagonals. Every convex polygon with 4 or more sides can be dissected or split into contiguous, touching triangles by the diagonals drawn from a single vertex. There are only 2 ways to dissect a quadrilateral into 2 contiguous triangular regions, and that would be like this or like this. There are 5 ways to dissect a pentagon into 3 contiguous triangular regions. So like this. So here we have 3 triangles. 1, 2, 3. We could also divide it from this vertex, so that would be 1, 2, 3, and so on. Every convex polygon with 4 or more sides can be dissected into contiguous triangles by the diagonals drawn from a single vertex. Imagine dissecting a hexagon through one vertex into contiguous triangular regions. How many triangles will there be in any dissection? Alright, so if we just pick a random vertex, say this one, and we draw diagonals from this vertex, so lines to any other vertex that's not adjacent, so not this one and not that one, but we can draw a line there, there, there. So then, how many triangles are there? 1, 2, 3, 4. So there are 3 diagonals at each vertex, 1, 2, 3, creating 4 triangular regions. Let's put 2 ideas together. The sum of the measures of the angles of a triangle is exactly 180 degrees. Every convex polygon with 4 or more sides can be dissected into contiguous triangles by the diagonals drawn from a single vertex. Question: what is the sum of the interior angles of PQRS? Well, here we have our answer. We can go through it. So we've dissected this into two triangles, and that allows us to turn the problem into something that we know how to solve. So this angle plus this angle plus this angle equals 180, and this angle plus this angle plus this angle equals 180. Therefore, if you add up all of these angles, they would add up to 360, which is 180 times 2, because there's two triangles here. Every convex polygon with 4 or more sides can be dissected into contiguous triangles by the diagonals drawn from a single vertex. What is the sum of the interior angles of a regular pentagon? Alright, so we choose this vertex, we draw diagonals. Now we have 3 triangles in here. So if you have 3 triangles, which means that this angle plus this angle plus this angle equals 180, this angle plus this angle plus this angle equals 180, and this angle plus this angle plus this angle equals 180, all you have to do is take 180 and multiply it by 3, and you get 540 degrees. All of these angles added together equal 540 degrees. What is the sum of the interior angles of an octagon? Alright, so here we have 8 sides, so we have a single vertex. We draw our diagonals, all possible diagonals. How many triangles do we have here? 1, 2, 3, 4, 5, 6. So 6 times 180 gives us 1080 degrees. Every convex polygon with 4 or more sides can be dissected into contiguous triangles by diagonals drawn from a single vertex. Use this idea to complete the table below. Alright, so here we have number of sides of a convex polygon, the number of contiguous triangles that you can draw, and the sum of the interior angles. So here we have a triangle, therefore the sum of the interior angles is 180 degrees. Here we have a quadrilateral with 4 sides. We can divide that up into 2 triangles, therefore that's 180 plus 180 gives us 360. Alright, here we have 3 triangles. This is a 5-sided polygon. We can draw 1, 2, 3 triangles, therefore 3 times 180 gives us 540 degrees as the sum of the interior angles. Alright, if we have a 6-sided convex polygon, then how many triangles can we draw? 4. So we have a vertex, we can draw diagonals like this, and that is 1, 2, 3, 4 triangles. 4 times 180 gives us 720 degrees as the sum of the interior angles. Now what's the rule that we can write? If you have n sides, that means that you can draw n minus 2 triangles, so like 3 minus 2 gives you 1, 4 minus 2 gives you 2, 5 minus 2 gives us 3, 6 sides minus 2 gives us 4 triangles, so we have n minus 2, and that gives us n minus 2 times 180 degrees as the sum of the interior angles. Polygon interior angles theorem. The sum of the measures of the interior angles of a convex polygon with n sides is 180 times n minus 2. Let's complete the table. So if we have a heptagon with 7 sides, that would be 180 times 7 minus 2, which is 900 degrees. An octagon with 8 sides would be 180 times 8 minus 2, which equals 1080 degrees. A nonagon with 9 sides would be 180 times 9 minus 2, which is 1260. A decagon has 10 sides, so that would be 180 times 10 minus 2, which is 1440 degrees. 11gon with 11 sides would be 180 times 11 minus 2, which is 1620 degrees. And a dodecagon with 12 sides would be 180 times 12 minus 2, which is 1800 degrees.